Hello everyone. My name is Darren Yandem, and in this session, within the next 40 minutes, what we're gonna do is, as the title suggests, we're gonna look into Microsoft's Azure Cloud and see what's in it for IoT developers. For us who are gonna build IoT stuff, and how can a cloud platform like Azure be helpful, what pieces, what services from Azure might be of use when we're building new IoT solutions. So I'm gonna start straight with this big picture. These are all of the services from Azure that you might touch or you might end up finding when you do a research for your requirements. This is pretty much most of the services, not all of the Azure services, but most of the services it relates to. Again, most of our requirements when building IoT solutions, and as you might see, those are partitioned across essentially 4 different segments. It starts from the lower level, goes to the higher level, and obviously just as a disclaimer, we're not going to be able to deep dive on all of this. But I wanted to give you the big picture so that you know at least most of the keywords out there and the services and the offerings available from IoT. When you start from the device connectivity, event hubs, service bus, are the main pieces used to deliver communication between devices, which is what I'm going to try to focus on this particular talk. And then if you jump into the storage, obviously the requirements changes based on the based on what you're building. You might want a relational SQL database, or non-relational essential NoSQL databases, and different forms of NoSQL databases. You might want to know, a key value type of store, or a document store, or maybe a graph database, which isn't included in this slide deck, but it is available as a separated service. Actually, Microsoft combined the DocDB with the table storage, and they came up with this new service called Cosmos DB. It's essentially a global distributed database where you can create replica in any of the Azure data centers that you want, which is a simple checkbox on the Azure portal, and then you can have a single storage system where you pick what API layer you want to use on top of it. Do you want to use an API layer with what's going to help you implement key value, or do you want to use an API layer where it's going to show you the underlying infrastructure as a graph database? So the underlying infrastructure, Microsoft combined all of that. They have a single engine, but then they separated the upper layers. And when you create a service account, you simply pick your layer, the API layer that you're going to use, and then you can start using it the way it's like a document type database, or key value database, or a graph database, but the underlying infrastructure is the same. There are some good amount of projection going on there, and that's why the product's name have been a little bit changed, and today it's called Cosmos DB instead of DocDB. But if you go out and start searching for documents and documentation about the products, you might see a lot of DocumentDB documentation that essentially works with the current renamed or revamped Cosmos DB. So long story short, it doesn't matter what you need, to be honest. In this case, if you want a NoSQL or different types of NoSQLs you need, that there are services within Azure that you can use. If you want to have a relationally consistent store, then SQL is there, you can use. There's even I didn't see a lot in the IoT space, but even if you are looking for something like MySQL, it's available as well if you are looking for something lower cost and keep things small or whatever. So when we jump to the third partition, third segment here, it's the analytics, and you might notice that we kind of start from the low level, like connectivity issues, and then storage, and then now higher level stuff like how do I make sense of all this data that I have, type of thing. So in the analytics space, obviously there are different products as well. Do you want to use your own R code and go with the machine learning? You can do that. Do you just want to get huge amounts of telemetry ingested within Azure and then run some MapReduce on it and come up with some data out of it? Then stream analytics might be your thing, which relates a lot to the demo that I'm gonna do next. We're gonna create a fake device that's gonna send some humidity and temperature data to Azure, and then from that data you can actually use stream analytics to create meaning out of it. Obviously the next step would be the machine learning, and the final segment is presentation and action, which means obviously we're going to show this data in some UI layer or in an app or somewhere. Then you need some kind of a hosting space. If it's a web app, it might be an app service. If it's a mobile app, it might be something that is higher level that can help you expose APIs faster, instead of hard coding all of this stuff and kind of manually doing that work. You might even go to Azure Functions in this case, which isn't in this list at this slide, but function as a service is definitely a good space to build some decent APIs, and notification is a critical part of it. Or you just want to show the data in some kind of a reporting UI, then Power BI and Power BI Embedded, which is something, something you can embed within your application and use it as a service. Instead of having people install a Power BI client, you can actually make it part of your product and host it within your product. It doesn't matter if it's a desktop or a web app. This is Power BI Embedded is relatively new, so it's not very well known that the ability to embed Power BI within a custom SaaS app isn't well known. So this is kind of the big picture, starting from device connectivity to the UI layer. And if we look at the reference architecture here, obviously based on your requirements and stuff, this can drastically change. But the idea is there are these devices out there, they're getting us data, or we're kind of pushing them events, right? And we essentially have three different problems. The three major problems are: how do I get the data that is created by IoT devices? How do I send them actions? And how do I preserve the state of a device, right? Even if it's a firmware thing or if it's a setting related to a device, how do I make sure the state that the device knows and the state that I know in the cloud about the same physical device is the same, is synchronized? How do I make sure that a state change about a particular device is something I can do in the cloud, even if the device is disconnected, is not connected to the internet, right? So the dream is obviously all of our devices are connected to the internet all the time, but it never happens. And some devices, they can't even talk on the HTTP, obviously, and that's why we got this thing called the gateway, which does all of the transformation, protocol transformation. But even if you are able to talk HTTP, then what you need to do is to make sure you can operate on a device even if the device isn't online. How do you do that? The way you do it is obviously if you go 101 level, then you need to keep the state in your database in the cloud or whatever you want to, and then you need to have a state on the device, and you need to make sure both are synchronized whenever it's possible, right? And as the cloud system and as the backend, you need to be aware of when it is synchronized, and you need to be aware of when it is stale, right? You need to know when was the last time you connected to that device. You need to know what was its last state, and so on and so forth. So those are all the problems that needs to be solved. And this isn't just one, obviously. Like I've said, they're getting a lot of data from millions of devices out there and sending them events or data so that they can take action according to that. So that's the communication layer. And if you go underneath, you end up building this event processing engine besides just the cloud gateway. You need to provision devices, you need to store the state, you need to get the telemetry, process it. First, store it in an efficient way so that you can store the incoming millions of messages, right? And then you need to process it, get something meaningful out of it, which is where the analytics and the machine learning part fits in, and then you present it or take action with it. So this, this is very much aligned with the previous slide that I had. A bunch of products and services listed in different segments, and this architecture overall maps to these layers on the previous slide. And so a little bit further, so far we did talk about the conceptual stuff, a little bit about the products, and if you go a little bit deeper into the implementation, what's going on. What are the exact pieces from Azure that's going to help me out? So the biggest piece here is obviously the product called Azure IoT Hub. As the name suggests, this is a specific service built for IoT developers for their requirements. So far we did list a lot of products, right? Relational databases, non-relational storage systems, Event Hub and Service Bus, communication products that can help you communicate devices which are online or offline, and queue communication, and so on and so forth. But these are all low level, right? Generic, if that's the right word. Generic products, not specifically designed for just the IoT developer, right? Because for an IoT developer, there's this thing called the device, right? We all have a device. So the concept of device does not exist in the world of Event Hub. In the world of Event Hub, there are applications talking to the Event Hub and sending events, and that's it, right? So a higher level product and service that consumes the products that we just listed in the first slide is what IoT Hub is. So IoT Hub in the back end, it uses Event Hubs, but because it's kind of harder to manage the Event Hub, if you come from the IoT world and with your requirements, you can use Event Hub to make things happen, but you're going to need to build some stuff on top of that, because that's just eventing, right? The IoT Hub itself uses different Microsoft Azure services, including the Event Hub, and then exposes a service which has concepts like protocol failover, which has concepts like the device itself, the device state, device twins, essentially, which has the concept of telemetry instead of just a message. And it has the concept of not just the IoT Hub, it has the SDKs that comes with it that helps IoT developers to start using these services. And again, this is specifically designed, with the requirements of an IoT developer and an IoT solution in mind. That's why right now you are what you're seeing in the slide deck is things like AMQP, HTTPS, right? MQTT. So these are the protocols that the IoT Hub can play with, can transform it. It can even make it, the SDKs even can make it transparent to you. You don't need to worry what the current platform supports. It's going to find it out itself and try to communicate with that. You can obviously define it, on your own, manually override, but, the idea is both the SDK and the backend services makes it as easy as possible for the developer to start, building solutions. That's the thing. And behind the IoT Hub, the event processing happens automatically, and you can the event ingestion, so it happens automatically, and you can process the events. You can implement your business logic the way you want, and you can build applications on top of it. But this right side of the screen that you are seeing, the three red squares, are the squares that you're gonna fill in with other services from Azure. So IoT Hub will be the place where your devices out there will be talking to persist their state. The state management, device to win, will handle that. The state management will be done. You don't need to do anything about it. It's handled. There's this IoT Hub knows about this problem and tries to fix it. And then there's the telemetry, device to cloud, cloud to device messaging. That is out of the box with IoT Hub. And if you want to have more, if you want to have more of this, coming out of the box, so to say, if for you, it sounds a little bit, daunting to build. Hey, I don't want to even build the back-end processing. I don't want to start from scratch. You're going to need to build something, but obviously, if you don't want to start from scratch with event processing and all that stuff, there's this thing called IoT Suite. So IoT Suite itself is actually an open source project that is on GitHub. And IoT Suite has a couple of scenarios. Essentially what you're going to need to do is, I'm not going to go deep into the IoT Suite because they are very specifically crafted and tailored for some industry scenarios. You're just going to need to do some Googling and go to the IoT Suite website, and then look for the scenarios. If any of these scenarios make sense to you, even half of it, right? Even half of the scenario out there is reusable. What you can do is you can go to the Azure IoT Suite website. You can deploy it straight from there to your Azure subscription. And when you deploy it with its default settings, it doesn't only do the IoT Hub stuff, it has even its own, reporting web application, right? Things like that. So again, that is very well crafted to particular scenarios, but keep in mind that it is open source out there on GitHub, so that you can download and maybe fine tune some pieces of it, change it, and then start using it. It is kind of a helper that's going to help you, fill in the three red squares that you see on the right side of the screen right now, and without essentially building it from scratch. So the story starts with the with the provisioning of the device. You need to first of all you plan what you're gonna do, the rollout, and then you need to provision your devices in a secure fashion and know that they're in the field, and then you need to push some kind of a configuration right to the device, and then you need to monitor it. Monitoring means that there is health monitoring or telemetry monitoring. And then when the moment comes, you're gonna need to retire the device or replace the device, and all of these scenarios needs to be handled within IoT Hub, and that's what IoT Hub does, because it provides bidirectional communication in a secure fashion. You can have per device authentication, which is the default setting in IoT Hub. Every device registers itself and then receives a key to be able to communicate to IoT Hub. And then what we have is device to cloud telemetry. Devices are able to send data to the cloud, telemetry data, and then we got the other direction, which is cloud to device commands. I noticed at the beginning of this presentation I said events, but that's kind of the same thing. You can send commands or events from the cloud to your devices. And then you got device monitoring. You need to know if a particular device is connected or not, and so on and so forth. And all these features, they all support multiple protocols. You can have AMQP HTTP or use the MQTT IoT gateway to accomplish that as well. So with that, I'm gonna jump straight into the demos here, because I do have a sample solution here that I want to show you to to explain how this all works. The demos that I'm gonna do will be related to bidirectional communication mainly, the provisioning, and then the bidirectional communication. Let's start with the Azure portal first. Let me go here. So I'm gonna zoom in. So when you go into the Azure portal, the thing that you need to do is to create an IoT Hub service. So once you do that, it's going to give you an endpoint. The amount of messages that you see right now here, 8,000 messages, are actually this is actually the free tier, and the 466 messages I used was during the testing I did just before this session. So I do have an IoT Hub account created here, and my solution right now is able to talk to it. That's how I set up my demo. So this is the host name, this is the endpoint that we're going to talk to, and you get actually a token to be able to talk to that IoT Hub account. So the first thing we're going to look into is the simulated device experience. Oh, no, sorry. Before that, we need to do registration. So we are going to do device registration through IoT Hub. When the device boots up for the first time or during the provisioning, you're going to need to talk to IoT Hub and then register your device so that for the rest of the timeline, for the rest of the communication channels, the device will be using its own key. And that's how the state and communication and everything, the identity of the device, it has a key and the name, and that's how the whole thing works. So in this example, let me make this a little bit bigger because I know the resolution on your end isn't that high. So what I'm doing is, these are pretty simple console applications, by the way, and I'm using the .NET SDK, the IoT Hub .NET SDK. Let me go there and show you what I'm using. When I go into the NuGet packages and go into the what's being installed, I do have Microsoft Azure devices, the shared library, and the MQP, and so on and so forth. I do have some other stuff that I'm using in this solution, but the critical stuff is essentially the Microsoft Azure devices library. Let me go back here. So essentially, when we start this console app, what I do is I do have the connection string, which is the connection string that helps me connect to my IoT Hub account. I'm using a key, which I'm gonna try to hide as much as I can. So with the connection string, we create the registry manager, okay, and then I call this method, which essentially register this device, and that's kind of it. So you need to give a device ID. In this case, I'm given something that makes sense so that we can see and figure out when the device is in IoT Hub's own portal. And I'm calling it device async, giving the device ID, and then I'm gonna get the primary key that's gonna be used for all the communication, right? For future, telemetry, device to cloud, and cloud to device communication. Let me start this, set it up as a startup, and then actually I can run it straightforward. Okay, there we go. Let me zoom in. So this is the generated device key that the device needs to save somewhere so that we can use it. Okay, so registration has been completed, so I'm gonna move this somewhere here so that we can reuse it, and I'm gonna kill this process. When we go back to the Azure portal right now and go into Device Explorer here, this is where you can see all of the devices registered to your IoT Hub. And as you see, we got a device called My First Device. This is enabled. We got the primary and secondary connection strings that we can get from here. We can even do some, if you want to do some kind of a debugging or testing, most probably you're not going to use these this portal for production, but you can straight send a message from the Azure portal to this device. You can edit the device twin, which is going to have all of the state information and the configuration related to this device. This is going to be where we're going to store it. It's not part of my demo. We can make it in time, but you can see all that stuff in here. So let me go back to Visual Studio. Now that we got a device registered and we got the primary key, let's start sending some telemetry data, right? So I'm going to need to replace this key here, device key that I just registered. So this is another console application, and imagine this being our device and the code that works within the device. I'm going to use a device client that comes with the SDK. And what I need is the IoT Hub URI and my device key, which I got after the initial registration. So here I'm creating a device client, giving the URI, my name, my key, and the protocol. So in this case, I wanted to force the app. You can leave it, it's an optional parameter. You can leave it. Then the SDK will try to pick the best, based on the platform, based on the SDK that you are using. But if you want, you can definitely force what protocol to be used. And then this method is gonna work, which is gonna create some dummy, fake data, temperature and humidity. And what I do is that I create some, custom objects out of it. I serialize it to JSON, and then I create a message out of it. And this message comes from the. Let's go here and let me show you that. Comes from the Azure SDK again, Microsoft Azure Devices.client. Assembly. So I'm creating a message, and finally I call the send event async from this device client that I created prior to this function. I call send event async and send my message, and that's it. Just for the sake of the demo, I'll output it for the to the console so that we can see. So and that's kind of it. I mean, that's all you need to do. I mean, we can have this code running on millions of devices, sending telemetry data, and IoT Hub will handle the rest. Obviously, there are things like partitioning if you're using Event Hub, but IoT Hub manages partitioning in its own. You just, we're not going to talk about the pricing right now, but you just need to scale your IoT Hub units. And when you do that, you don't need to worry about anything else. You're just gonna receive whatever amounts of data that you got. Essentially, you just need to pay for it. So let me run this thing and see if it really works. It was before the presentation, but okay. So if I'm lucky, okay, there you go. So we already sent 3 messages, so right now it's working. It's going to take a while for the Azure portal to update its message count here. Let me go back and go to the overview. Right now we got, it already updated it. So this was 466, right? So we got 467. But I guess this message is the registration. It didn't update for the messages that we just sent yet. So we're gonna say it. This is still sending telemetry messages. So what about if I? So let me go back to my samples here. In all these samples, I'm gonna give the link to the source code at the end of the presentation. But so right now, let's focus what we have here. So we got the simulated device, and then we wanna read the messages that the device is sending from the cloud, right? So, and this is the part that relates to that, reading device to cloud messages, right? This is the part that is supposed to be your backend in the cloud. So what we do here is, again, we got a connection string. This is the part that we're gonna focus on the event hubs, because like I've said, IoT Hub is using the event hubs underlying structure. You can definitely create different pipelines, but let's not go into that for now. And here what I do is I use actually the Event Hubs SDK, the Service Bus SDK, and create an Event Hub client. I do get all of the partitions because IoT Hub on itself can create multiple partitions. It happens transparently in the backend where you are sending telemetry data. But here, while you do reading, because we are essentially using the Event Hub straight, not the IoT Hub, we need to worry about the partitions. So in this case, I'm getting the partition IDs and iterating through them and creating readers for every partition ID. So for every partition, you can have up to 5 readers. When you read the data, it's going to be deleted. It's going to be kept there for 7 days until you read it. So this is, keep in mind that this is the processing engine actually that we're doing right now. I'm just going to read and output some stuff to the console, but what you're going to need to do here is to read and process, or read and move it somewhere else, because IoT Hub isn't the place to store your data forever, right? You just ingest all of the telemetry and you just move it somewhere else. And this is where I'm creating the listeners, and every listener has a consumer group, obviously. I'm getting the receiver, and here I call receive a sync, and I get my message converted to a string so that I can output it on the console, just for the sake of this example. And that's kind of it. That's all we need. Oh, one little thing before I close this thing up. You might have noticed, or I need to show here. Okay, here's the thing. When I'm creating the receiver, the 2 parameters that I give is the partition and then a date time span, not essentially time span. Anyways, the current time. So the reason I'm doing this is just for the demo purposes, I am starting my read cursor from the current time. If I would say, like, I don't know, add minutes -5 or whatever, I will start reading from, right now, when we send data, telemetry messages to IoT Hub, they do persist there until someone reads it. So this isn't the right implementation for production. You would like to read the old data as well, obviously, but just to make this demo a little bit easier, I'm kind of, just to show you the real-time piece of it, I just said, get me all the data starting now. So we're never gonna see old data in this case. So let me run this thing. I'm gonna run the reader first. So it's waiting there. And now I'm gonna run the simulated device. So get both on the screen. 2 messages sent, 3 messages sent, and hopefully at some point, there you go, 4 or 5 messages received. I mean, at the beginning it received a bunch of messages altogether, but as you see, I mean, this is currently working on MQTT, and the device is sending telemetry, and the cloud piece is actually processing all of these, events. Let me close this thing and go back to the portal to see if the number has been updated. And for that, we're gonna need to do a refresh. Okay, there we go. It looks like we have sent around 30 messages here. And we only have 1 device registered. So this is how you read messages from the cloud. So how do you send messages from the cloud to the device, right? So let me show you that as well. This is the app in my sample set which says send cloud to device messages. So here again we got the connection string. We use the service client. This time this is again part of the IoT Hub SDK. We created out of the connection. For now, ignore this receive feedback async part. And this is the part when we send the message, send cloud device message async. And what it does is, again, it creates a message and it just sends it to the device by its name. So obviously we don't have the primary key in this case because we are the cloud part, the infrastructure, the backend part. We just know the name of, we need to know the name of the device and send it the message. In addition to a regular, a default operation, what I did here is to set the acknowledgement to full, which means as a sender, when I send a message, I want I want the platform to let me know if the message has been delivered or not. And that's the part that relates to the receive feedback async. And here, what I'm doing is I'm getting a feedback receiver from the service client, and in an indefinite loop, I'm calling for receive async and getting the feedback batch. In this case, just for this example, I'm just outputting it to the console, and I'm calling that the feedback has been received and it's completed. I don't need any other feedback for this particular instance. So, and this is gonna work with our simulated device. So let me run the simulated device again. So it's gonna start sending messages, and this time I'm gonna run the send cloud to device messages app. Okay, here we go. This is gonna send just a single message, by the way. I didn't build it in a way it could send multiple messages. I'm just trying to figure out how I can show you. Okay, this should be the right window setup. Okay, so here I'm gonna write something. Okay, test message, and now I'm gonna send it. So message received, and the acknowledgement, hopefully it's on its way. It takes a while for the acknowledgement to, and there we go. Received feedback, success. So like I said, right now this is gonna just shut down the server. It's just gonna be able to send one message, but you have seen how that works. So I can essentially run all of these apps locally, have read device to cloud, reading all of the messages from the cloud, and meanwhile sending messages from send to cloud messaging, and have acknowledgement as well. And I mean, my demos mainly were around .NET and using console apps, but you can use other languages as well. And I don't have top of my head the number of SDKs Microsoft has for different languages and platforms, but at least I can tell you this, that they're very eager to have developers use their platform. So definitely there are different SDKs for different platforms and languages, and they do have the same concept that I just we just demoed. And with this, you don't need to worry about the communication anymore. On top of this, what we got is the device to win, health monitoring, which wasn't part of my demo. But if you got the idea, like how easy it is to implement this thing without worrying about the backend and without worrying about the scalability of the backend, which is kind of the most critical part. I mean, you can come up with a small backend or a POC backend which can handle all of this stuff pretty easily. It's not a huge thing, besides the multiple protocols that you're gonna need to support. But getting this into a point where you can receive millions of telemetry messages every minute, then it's gonna be a challenge. Obviously, if you take the challenge, you might end up with a low-cost solution. I'm not going to say that IoT Hub, the Azure IoT Hub is cheap, but do you want to monetize it or not, which is the essential question about any platform, any cloud platform that you're going to pick. So back to the Azure IoT Suite. I know I said that there's a couple of different scenarios. And here are a couple of them, and why the Azure IoT Suite is out there. Go ahead, take a look at it. If it's if you're gonna do predictive maintenance, for example, you can start with the predictive maintenance scenario, get the source code from the GitHub repo, and start using it. It can really speed up your implementation. With that, this is all I have, and it looks like we have 1.5 minutes. So let me know. Let me go back. And by the way, I do have a list of resources as well here, which is my final slide. Let me show this for a couple of seconds here. You can grab a screenshot right now if you want, or I know that the team behind the conference is gonna share this slide deck with you. So watch for that as well. And if you go to GitHub and look for Azure IoT Remote Monitoring, Azure IoT SDKs, you're going to get all of the libraries that I used. If you are looking for the samples, go to aka.ms/Azure IoT samples. You can go to Azure IoT Development as well for additional resources. And if you are looking for the Azure IoT Suite scenarios, go to Microsoft Azure IoT Suite.com. So with all that said, let me go back to see if there are any questions. Okay, So you're gonna see this forever looping desktop. Sorry about that, I don't have a webcam. Is there an option for device to IoT Hub over the direct UDP connection? Not that I am aware of. I'm gonna say that much. Does it support all systems? So that's a very generic question. It definitely doesn't support all systems. That would be my answer. But it supports a bunch. So take a look at it. Is there a C library for Azure IoT devices based on running available also for running under? Yeah, that's a very good question. I don't know for sure because I'm not a C person, but let me try to find an answer to that question right now. And I'm gonna go to IoT SDKs here. Yes, there is a C library. Yeah, Azure IoT SDK for C, Python, Node, Java, and .NET is all we got. Yeah, where is the sample code? Okay, so we're out of time anyways. So let me go back to this resources slide deck and keep it there so that you guys can get the links. And that's gonna be it. Thank you for watching. If you guys have if you have any other questions or something comes to your mind after the session, which is this exact moment in time, hit me on Twitter. My name, last name is where I'm at, Darren Yandem. Hit me on Twitter. I'm gonna try to help you as much as I can. Thank you for watching and have a nice one.